Alright, let's try this out. Today we are going to be learning about how to write the names and formulas of ionic compounds that contain transition metal ions. If you don't remember, transition metals are the group of elements that are in groups 3 through 12. So they kind of sit in this region of the periodic table. Some notable transition metals or transition elements: we got iron, copper, silver, gold, platinum, tungsten, that is in light bulbs, titanium. Quite a few everyday metals are considered to be transition elements. We need to learn how to write formulas of their compounds. If you remember me telling you, metals like to form ions because they are readily willing to let go of their valence electrons. So if you remember from earlier in the week when we wrote compound formulas for ionic compounds, the important thing was that the oxidation numbers canceled out to zero. So on Monday we were practicing with binary ionic compounds like salt. So we had a sodium ion, Na+, Cl-. The oxidation numbers, +1, -1. We want to make sure that when we're done, that I have just as many pluses as minuses, so that when I write the final formula for the compound, NaCl, they cancel each other out. Then on Tuesday we started learning about compounds that contain polyatomic ions, and those are the ions that you can find on page 158 of your textbook. So we used an example like sodium ions and carbonate, CO3 2-. Here you can see that the pluses and minuses don't cancel out. If I have +1 here and -2 here, then I would end up with an overall charge of -1. So what I have to do is add another sodium. When I do that, I write the formula as Na2, because I had two sodiums, CO3. Last thing we learned about on Tuesday was how to write a formula if we had more than one polyatomic ion. So if I wrote the formula for the compound that is magnesium nitrate, magnesium is +2, nitrate is -1. So in this case, I need an extra nitrate to balance out the oxidation numbers. So I'd add 2 nitrates. In the following formula, I would have Mg. This time we need to put a parenthesis here. Nitrate, NO3, and parentheses 2. This 2 came from this 2. I need to put a parenthesis so that it doesn't look like I have 32 oxygens, but instead show that I have 2 nitrates. So now the last thing, once again, to remind you, today we're going to talk about how to write ionic compounds with transition elements. So that's groups 3 through 12. The interesting thing about transition metal ions are that they can have multiple oxidation numbers. That means more than one. If you look, there's a table of these on page 164 of your textbook. Let's look at 2 example compounds. If I gave you the name iron oxide, iron oxide. You would know that the IDE at the end means that you would be taking that from the periodic table, oxygen. Iron oxide, as long as we knew what the oxidation number for iron is, would be pretty easy to write. However, we don't. If you look at the table on page 164, you can see that there are two different possible oxidation numbers for iron. There's iron 2 and iron 3. These are given the symbols. When we write them out, we would say iron and then write a Roman numeral 2, and this one would be iron Roman numeral 3. The Roman numeral is the same as the charge of the metal cation. So if I want to write the formula for iron oxide, I need to specify which iron I'm using. So that's what I'm going to do. Shrink these down just a little bit. Put them away for a moment. Maybe just get rid of them. So, for a compound that contains iron 2 with oxygen, we know the oxide ion, since it's in group 16, is 2-. So those cancel each other out immediately. 2 minus 2 is 0, so we would just write FeO, the ugly chemical. Ha 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 ha. The next one, iron 3, Fe3 plus for iron 3 with O 2-. See, this one does not cancel out. This is similar to the one where we used aluminum and sulfate. So this time I need to put 2 irons because 2 times 3 is positive 6 and 3 times negative 2 is negative 6. And I write the formula as Fe2O3. Based on our old naming system, both of these would be called iron oxide. However, we can't do that anymore because these are two different chemicals. One is oxide of iron and one is another. One of these is rust. It's actually the second one. So let me show you how we name these. Remember how we called this one? We said that was called iron 2 because the 2 is the same as the charge of the metal cation, right? So that's iron 2 oxide. And then the next one, I'm going to try and guess. It's going to be iron 3 oxide. Once again, try and remember, it's not the number of irons that you have, it's the charge of the cation. So you can see, even though this one's called iron 3, there's 2 irons in the final compound. And this one's called iron 2, there's only 1 iron in the final compound. This number here is the same as the charge of the cation. So I'd like you to practice this for just a minute. So I'm going to switch screens. I'm going to give you 2 examples. I'm going to give you one where I give you the formula and you have to write the name. And then I'm going to give you one that is a name and I want you to write the formula. Okay? So the first one I'm going to give you is one that contains also a polyatomic ion. And the second one, I'm going to write the name. For those of you that are unfamiliar with Roman numerals, this is the number 4. Okay? So have your sub pause the movie briefly so you can try those two in your notes. And then when you are ready, press play again for the solution. Okay, let's see how we did. The easiest way to do this is by looking at the anion first. In this case, it's a polyatomic anion, which is SO4, 2 minus, or sulfate. Now what I need to do is consider that I only have one manganese. So for manganese to be able to balance out with sulfate, it would also have to be 2 plus. So the name of this compound would be manganese 2 sulfate. Remember, it's not the number of manganese atoms that there are. This number 2 is the same as this number 2. That's where it comes from. The second one, to write the formula, is pretty easy. Nickel is Ni, and this 4 indicates that it is a plus 4 cation. Nitrate is NO3 with only a minus 1 charge. You can see the charges don't balance out. So I need to have 4 nitrates for every 1 nickel. And I would write it as Ni parentheses NO3 end parentheses 4. You'll get some more practice at this. There are some steps for how to write the formulas for these compounds in your book if you look on page 164 and 165. What I'd like you to do now is continue your work from earlier in the week and do practice problems 5 and 6 on page 165. So go ahead and add those to problems 1 and 2 from page 158 and 3 and 4 from page 162. Remember, these were 5.1 practice problems. And if you finish all 6 problems, go ahead and put your name on it and turn it into the box. And I can answer any questions that you have on Monday. Be good for the sub. Talk to you guys soon.